So my name is Aaron Hawkins. I'm a professor in the Electrical and Computer Engineering Department. I'm coming to you live from my office here at BYU in Provo, Utah. And welcome to everyone watching live and to anyone who will watch this as a recording in the future. Since this is the first of these presentations that we are going to do, I thought I would share a little bit of how they came to be and what our intention is. Many of you may not know that we have an external advisory board for the department. This is not a picture of them. This is a stock photo of conference room. We'll need to take a picture of them in the future. The function of our external advisory board is to give us advice and feedback, what we're doing right and wrong as far as our student product is concerned. Many of our advisory board members are alumni of our department, so we're also interested in their opinions on how to connect with our alumni base. And one of the suggestions they gave us was talks like this. They would be a way to connect the university and faculty to alumni, give alumni a chance to learn something new. And the idea is we'll do this on a lunch break. It's semi-formal, a live and recorded version. And someone suggested that other people had their colleagues, their alma mater would call these coffee talks. Well, we don't have a lot of coffee here at BYU, so the code name for this project became Postum Talks. Let me give you a little tangent on Postum for those of you who aren't familiar with Postum. When I was growing up, this was kind of a popular alternative to coffee. It wasn't that popular, but it was a warm beverage made from grains, barley, and I'm not sure how much it really tastes like coffee. Postum kind of disappeared for a while, but it's back. If you go searching for it in stores, you can find it or find it online. And so this is codename Postum Talks. Anyway, so what we're hoping for with these tech talks or Postum Talks going forward is that we'll plan on doing them once a month and on a Friday at noon, and invite all of our alumni and even our student current student population. We want to explore some broad appeal topics that aren't that hard to grasp. You don't have to do too much thinking. We'll make these about 30 minutes long. Maybe it'll run a little longer than that. And we'll live stream as well as save this for our YouTube channel and post it later. Our first speakers are going to come from our faculty. And then eventually we would like to involve alumni speakers. So in the future, we'll be asking for nominations for Postum Talks and who can share something interesting with the group. Now, today, if you have questions as I'm talking, I hope you can put them in the Q&A tab on the bottom of the Zoom window, and then we'll try to get to some of those questions as we go or at the end. So for this first talk, I tried to come up with a topic that was something fairly fun and broad interest that has gotten, well, maybe some PR in the past. You can kind of gauge whether something is broad interest or not if the university's communications or PR team wants to do a story on it. So the thing lately that I've been involved with where they were interested was something they called the world's smallest Book of Mormon. So that's what I'm going to talk about today and give you some behind the scenes look at how this developed. But since they've gone to the trouble of making a nice little video introduction of this project, I'm going to start by watching this. It's just a little over a minute, and they like to make it a human feel-good story. So let's watch.
Literal text of the Book of Mormon. You can read it just like you would read it out of your scriptures, as long as you have a microscope. That was the goal, is to put all the scriptures on something that was that big. It's about 25 by 35 micrometers for a single letter. The other scriptures that we put on these wafers were the New Testament and the Old Testament of the Bible. We created these wafers using the same processes that we would use to create a computer chip. Like Moroni himself, we were etching into this wafer so it is physically engraved. We decided to coat it in a thin layer of gold, paying respect to the original gold plates that we get the Book of Mormon from. The electronic storage that we have will degrade over time, but this, it'll last millions of years. I'll be proud to tell people that I was a part of creating the smallest Book of Mormon ever.
Okay, so now a little bit more about how that all got started. New ideas I've found come when usually when you're talking about something else. There are tangents in the conversation, little bits of gossamer that float through your head. I was in a research meeting with some undergraduate students, and we weren't talking about microscriptures, but one of them mentioned that he had seen something about the world's smallest Bible, and it was so small that it fit on a grain of rice. And then we got to talking about, oh, well, why couldn't we do that with the Book of Mormon? And thought it was a pretty good idea. And then things kind of snowballed from there. I went back and looked at what the world's smallest Bible, how it was made, and they call it the Nano Bible, and it really does fit on a 0.5 millimeter by a 0.5 millimeter chip, and it is written with ion beams and done from a university in Israel. And I want to go to a CNN snippet that talks about that little development. It's a lot like the BYU video we just saw. So let's see if this will work.
Using an ion beam to create a nanobible may sound like the stuff of science fiction, but that's exactly how scientists created the world's smallest Bible. The writing is so tiny, you need an electron microscope to read the 1.2 billion letters of the Hebrew Bible.
So in this sense, we have the newest technology with ancient words that still they have relevance for modern people.
The Bible is an experiment in miniaturization to see how much data can be stored in the smallest possible way. In a clean room at Technion, Israel Institute of Technology in Haifa, scientists created a layer of silicon less than 100 atoms thick, the size of a single cell membrane, then plated it in gold. Using a focused ion beam, scientists engraved the letters one bit at a time, blasting away the gold to reveal the darker silicon beneath. The nanobible is so small, its entire content would fit on the tip of his pen. You'd have to magnify the words about 10,000 times before you can read them. The nanobible is on display as part of the Israel Museum's 50th anniversary exhibition. It sits next to the Dead Sea Scrolls, considered one of the oldest and most important surviving texts of the Bible, dating back nearly 2,000 years.
Our objects, they represent the entire narrative of material cultural history from a place to that as important to that history as Jerusalem is.
The Nano Bible is a new way to look at history, combining the ancient words that never change with modern technology that is always changing. Oren Lieberman, CNN Jerusalem.
Okay. So that is the Nano Bible, and we're going to rely on some of those principles when we created our Book of Mormon. So we felt like, well, if somebody could do this with the Bible, we kind of have a moral obligation to do it with the Book of Mormon. And who else is going to do it but BYU? We have a clean room with the same kind of technologies as the facilities shown in that CNN article in Israel. So why not do it with the Book of Mormon? So if you've been in the Clyde building, you probably have seen the clean room on the 4th floor. Many of you have even been inside the clean room and experienced all that. So when we decided to do this with the Book of Mormon, we wanted to use a photolithography process. And this is not what you'd consider research, because we do photolithography all the time, every day. But a lot of our students are assigned to projects we call outreach or education. And so we categorize this Book of Mormon work as an outreach project. And we wanted them to create these wafers so that we could hang them on the wall as a demonstration of size and how lithography works to begin with. So we started off by doing a back of the envelope calculation. If we had a wafer, 100mm wafer, which we typically use, and we knew how many characters were in the Book of Mormon, could we easily fit all of these characters on the wafer using standard lithography without trying to push it too far? So that was our first calculation, and things seemed fairly comfortable. It actually works quite well with our lithography tools. When you're doing photolithography, everything starts with a photomask. Photomask is a square piece of glass, and on one side of it there are tiny metal features that are left on the glass, and those metal features are created much like that ion lithography that we saw with the Nano Bible, one at a time in a serial fashion. Once you have the lithography mask, you can do everything in parallel and print your pattern directly on your wafer. So you're seeing on the right some glass photomasks held in people's hands. These are 5 inches by 5 inches. And then on the left, you can see that the features on the photomasks are really tiny when you magnify them up with a microscope, and they will do a 1-to-1 pattern transfer to your wafer. So if we want micron size letters of the Book of Mormon, the metal features on the mask need to be that size as well. I thought the only tricky part of this little project was going to be getting text into the polygon metal features on the photomask. So when we found students willing to do this, I set them off to try to figure out a way to get text onto the mask. And I thought this would take a while, but next day they came back and said, we've got it figured out. So they started Googling and found that someone had already written a Python script to take a string and pass it into a program called K-Layout, and K-Layout then produces the design that goes on the Photomask. So they then created another Python script to pull in the text, pass it in as strings into K-Layout. Now, those of you who do microelectronics design, you probably know Cadence really well. K-Layout is the free version of Cadence, not as powerful, but it works pretty well at the university level. Now, once the design has been made, it'll send out a file that we then use to make a physical mask. Our clean room has a machine to create photomasks, but occasionally something in our clean room will be broken. And at the time, our mask writer was broken. So we sent these to a commercial mask writing house that produced these for us. So a shout out to Front Range Photomask in Las Vegas, who produced the masks for these projects. Okay, so we've got a photomask. Here's how we transfer that into a wafer. First, we coat the wafer with a photosensitive chemical. Photoresist starts off as a liquid. We spin it to a thin thickness on the wafer, then harden it, then put the photomask on top of it, as illustrated there, illuminate it with UV light, and then develop it like you used to develop film. And then you're left with that pattern in the photoresist sitting on your wafer. The wafer then gets put into an ion etching machine, illustrated on the right. Ions get pounded into the surface of the wafer. The photoresist protects some of the surface, but not other parts. And then you etch, dig holes into the silicon, and all this happens at the same time. All of your letters are getting created at the same time in your machine. So then you take the wafer out, pull off the resist, and you're left with that pattern now in silicon. So we wanted to, once the etching was done, also add a coating. So with the Book of Mormon, we put a gold coating on the top using E-beam evaporation. Wafer goes into a vacuum chamber. You heat up a little pool of metal and then catch the vapors on the wafer. There's only 100 nanometers of gold on the surface, but that is thick enough to make you think that is pure gold. So on the right, you're seeing a photograph of a finished wafer. The square on the circle, that's where the actual text is. We only needed that amount of area to get all of the characters from the Book of Mormon. While we were doing the Book of Mormon, we also did the Old Testament and the New Testament, and used different amount of different areas because the different text sizes or total text. But then we also coated them with different colors. The New Testament has an aluminum coating. The Old Testament, it appears blue. That isn't a metal coating. It's actually a silicon dioxide that was grown on the surface. And you're seeing it blue. It's an optical interference effect that makes it appear blue. So you're seeing here the smooth side of a wafer. Wafer has a smooth side and then a rough side. To see the letters as cleanly as this is about 100 times magnification. We need to look at the smooth side of it. Okay, so now we're looking at the entire wafer here. And there's Book of Mormon, Old Testament, New Testament. The square in the middle is how much area you needed to get all of those characters in. So this is a nice visual representation of just how the total number of words compares in these three books. Now we're looking at the back side of the wafer. We also put the pattern in the back side of some wafers, the rough side. It's easier to see it with your eye and take a picture of it on the rough side because on the smooth side, it looks just like a mirror. And taking a picture of it is, very, very challenging, and you don't see much. But the rough side, very gratifying to look at. All right, so if we zoom farther in and use a microscope, good microscope, to look at an individual letter, this is how small each of those letters was. We're using 5 micron line width, and so each letter is about 25 by 35 microns. And if you do, in the middle picture, this is called a 3D profilometer. We're looking at how deep each letter was etched down to about 20 microns, so it appears dark on the wafer. And then over on the right, this is a standard camera, so what you see with your eye. On the top were some big letters, and then on the bottom was the actual text, which you're not going to see that with your eye at all. Now, that's fairly small, but many people ask me, well, what process node did you use to make these wafers? Well, process node refers to the feature size, and it's an offshoot of Moore's law. On this graph, you can see on the left side, it's a logarithmic scale showing feature size, lithography feature size versus year. As time has marched on, we've made circuits, transistors that are smaller and smaller so that the state of the art is in the nanometer range. At most university clean rooms, we're still operating up in the micron range. So BYU lithography, we can only do microns comfortably. We have said goodbye to state-of-the-art lithography decades ago. But an interesting thought experiment is if you could make these Book of Mormon wafers at 5 nanometer line widths instead of 5 microns, how many could you fit on the wafer? So calculating that out, you could get the whole Book of Mormon onto the size of a letter that we used in micron scale lithography. So that would mean 3.3 million copies comfortably on a 100 millimeter wafer. To read it, however, you'd need a really good electron microscope. I don't think that one shown would be good enough to see those letters accurately. So it'd be tough to read, but you'd have a lot of copies. Another thought experiment, what if you could use even bigger wafers? So state of the art for wafers is 300 millimeters and not 100 millimeters. If you could make your tiny nano Book of Mormons on 300 millimeter wafers, you could put 30 million copies on each wafer, which is it takes 6 wafers to equal the total number of Book of Mormons ever printed. So if the church decided they wanted to just pump out lots of Book of Mormons, this is probably the way to do it. You could be billions of Book of Mormons fairly quickly. Any of you doing cadence designs and want to do a little Easter egg, this might be a fun thing to put on a chip. Okay, so is this just for fun? Is there any practical use of microscriptures? Well, one, it's a nice display, and I have lots of people mailing me saying, can I get one of these wafers I could put on a wall and put it in a frame? That's certainly a fun thing to do. You got the whole of scriptures there. And this was our original motivation for doing it. We have built a little display box outside of our clean room that shows Old Testament, Book of Mormon, and New Testament wafers out in the hallway. So if you ever visit the Clyde building, you can see these in person, both the backside of the wafer and the polished front side of the wafer. So displays are an interesting thing. But another possible interesting application of this is a connection to your faith. Now, the people who worked on the Nano Bible and others have since created small versions of the Bible, Old Testament or New Testament, and put them in jewelry. They are no longer doing ion milling, they're doing lithography to make these. So they're producing little portions or chips from the wafer, cutting them into small pieces and embedding them in jewelry. So I thought at least, oh, this would make an interesting application for the Book of Mormon. Why not do that too? So think of a CTR ring or something like that, where you took a little chip that had the entire text of the Book of Mormon and embedded it on the ring. To me, this sounded like a good idea. We actually talked to people at Deseret Book and said, oh, we've got a good idea for you. How about some Book of Mormon rings? And they wanted to know how much it would cost. So I did a little calculation. If we were to have this done at a foundry with 200 millimeter wafers and say 4 millimeter by 4 millimeter die for the Book of Mormon. This is a classic microelectronics chip calculation. The more you make, the cheaper they get. So on the left, you saw, here's what I reported to Deseret Book, but they thought that was still too expensive. So far, no one's been willing to make the Book of Mormon jewelry, but that's an idea ready for someone to run with it. And I'll be happy to advise. Now, another possible application of microscriptures or micro books would be storing records for a long time. Let's say you wanted something that would last for not only years, but millennia. And you'd want it to be compact so you get lots of records in a small space, not degrade, and it would need to be technology independent. I thought DVDs were going to be around forever, but no longer the case. So how do you do that without a lot of cost and ensure that it lasts forever? This reminds me of an activity taking place, a project going on where they're trying to build a clock that will last for 10,000 years. It's happening right now in West Texas desert. It's a huge clock, and eventually they want to put it in Nevada. And this is funded by Jeff Bezos, is one of the funders. But having something that will last 10,000 years, you really got to think about materials and power, and your design is very different than if you want something that's efficient and cheap. Making it last pseudo forever is a whole different animal. Okay, so I thought if we were to make a 10,000 year Book of Mormon, what would it look like? Our letters that we're using actually turn out to be near perfect size because you can see them with a fairly simple microscope. Doesn't require an electron microscope or anything like that. You can put a lot of text in a small area. So if I had to do this, I think I would take some clear substrates, either gallium nitride or silicon carbide that are transparent. And I would find a microscope that could be illuminated with the sun, and you would need these transparent substrates so you could see through, but a fairly simple microscope. make sure the microscope parts wouldn't degrade over time. Then put those two things in a stone or concrete box, bury them, and 10,000 years, you should still be able to read whatever text is on the wafer fairly quickly. A lot longer than 10,000 years, probably. So, yeah, if you're interested in some long record storage, this might be a way to go. Okay, so the immediate future of Microscriptures. The church history library was actually interested in these. And so we made copies of these wafers, both front and back side, and sent some to the church history library. I think they are working on a display, so people will be able to see those. And then they sent copies to the Granite Mountain Records vault. And so they will be stored with all the other records of the church in Granite Mountain at some point. So maybe, you know, they will be seen many years from now, and we'll see. Okay, so that is the end of my thoughts on Microscriptures. I hope this stimulated some interesting questions or thoughts of your own. I think Allison has been collecting these. And Allison, do you have any questions that you've
not yet. I think people were just listening. So if anyone has any questions now, please post them in the Q&A and we will get to those. Maybe you explained it too well today.
I guess it was just too complete, or no one's listening, but either way. Okay, well, before we wrap up, if you are interested in that, you might also be interested in another project that I'm working on that doesn't have anything to do with Microscriptures, but it is about words and books. So I'm want to be known as a short story writer. I want to be Google synonymous with short stories. So I have my own webpage called 500 Ironic Stories. And every week I put a new short story up. So I'm looking for more readers. Please go and visit me and either read or listen to the story. I'd also love your backlinks so that Google finds me more easily. So yeah, I love to have you on the 500 Ironic Story.
Oh.
Okay, Allison, what?
Sorry to interrupt. We do have a question for you.
Okay.
How can I do photolithography at home?
How can you do photolithography at home? Well, it all comes down to that Photomask. If you could get a Photomask and something to apply your Photoresist, well, and then you could probably use like a UV flashlight to do the exposure, and then some liquid developer. So the supplies aren't that expensive. You could probably do lithography at home. The line widths can't be very good, and you would run into the problem of dust in the air falling on your patterns, which is why we do it in a clean room normally. But lithography, I don't know, it's not something I would necessarily recommend at home. The chemicals aren't that compatible with your kitchen or garage.
Interesting. So that was Brian Mazzeo asking that. So I think Brian's getting ready.
Yeah, don't get your family involved at home.
Garage there. So we have another question. Thomas Carlenzi joined a little late. He says, can you say more about how the non-Bible was written? I have not heard of the technology you mentioned.
How the Nano Bible was written?
He wrote non-Bible. I think he meant Nano Bible.
Okay,
yeah.
so
Sorry, Thomas.
the Nano Bible was done what I call in a serial way. You take a tiny beam of ions and direct it so it's either going to be on or off, and then you sweep it across the entire area of the wafer. So it's in that case, it was taking off a little bit of gold or not as you sweep it. So kind of like an old CRT screen where you sweep an electron beam everywhere to give you the video. But here the beam is really tiny, so you can make very tiny features across it, but it takes a long time. So that's why lithography is preferred when you're manufacturing something. It happens semi-instantly over the entire area.
Great, thank you. Next question, do you plan to make a copy with upper and lowercase letters?
We don't have any plans yet. Yeah, I'm not sure we'll make any other versions unless the request or need arrives.
So a follow-up on that, and then I actually have a question. The follow-up is, would a serif font work?
Would it? Yeah, it would just be a matter of programming L or K layout to produce those shapes. Yeah.
Where do you acquire the full text of the Book of Mormon in the first place?
That I'm not sure. We'll have to ask
Oh.
those students, but it didn't seem very hard.
Okay. Next question, besides importing the text into the layout tool, were there other challenges the students had to overcome?
Were there other challenges the students had to overcome? Pretty much, it's a very straightforward process. They do lithography all the time. So once you have the Photomask, it's relatively easy to do.
Okay. Any other questions? Maybe you could do a little sneak peek at next month's.
Okay, so next month we will have Dave Long give our talk, our Postum talk about icebergs. And he's been chasing icebergs all of his career, but recently he had to go back to the 1700 records and papers from the first explorers in Antarctica to confirm whether these icebergs were in the right place or not. So hoping it's a enlightening and a punny adventure for everyone.
Oh, yeah, guaranteed to be a few puns in that one. How did you get started writing stories?
Well, about 10 years ago, I published a novel, and I think I've always wanted to be a writer. I think anybody can be a writer. It doesn't take being an English major to do it. So, yeah.
Let's see. Keith says, could we have a website where we submit alumni talk ideas and a corresponding poll to vote on our favorites? That's a good idea, Keith. I can work on that.
Yeah.
Okay, I'll work on that. And what is an ironic story?
Well, irony is everywhere. Anything that's funny is funny because it's irony, where something happens that you didn't expect to happen. So actually, that's what an ironic story is, something that would make you laugh or say, oh, that I didn't see that coming.
Is it possible to record more than just text?
Is it possible to record more than just text on this way with lithography?
But I
Well,
assume that's what that means.
any kind of character you could record.
So must it be a character? So if my 5-year-old grandson drew a picture, I couldn't etch that using photolithography.
Well, you could, yeah, it would come out in that pattern.
Okay.
Okay, well, we don't want to take too long. So thanks to everyone who stopped by and paid attention. and ask questions. And hopefully we'll see you next month.